Just to let you know, John, I was listening to you in Death Valley. I understand that on Earth, the tilting would come from plate tectonics.
So from the Bradbury landing site, we knew we were seeing a different type of material, one we really haven't seen on Mars before. And we were hoping that as we proceeded to Glen Elg, we would see additional exposures of this type of material that we could investigate further, specifically with the Mastcam 100. Now, the class that is circled is about 3 centimeters across. It's roughly the size of the gravel that I'm holding in my hand. And you'll see that the perimeter has a very rounded shape. It's been worn by abrasion in a sediment transport process. As it's transported, it's bouncing along, interacting with other grains and the surface, and that wears away the edges until you have a very smooth surface, such as you see here in this pebble. And the key components of these gravels that we're seeing here are, one, the rounded shape, but also the size. These are too large to be transported by wind. The consensus of the science team is that these are water-transported gravels.
So we can step away from the idea that it was a single burst of water that ran down the canyon and built it all in a day. There's too many things that point away from that. A canyon that is about 11 miles long, 2,000 feet wide, and about 100 feet deep. And that canyon was cut by stream flows, and that stream and sediment then entered the crater rim wall and spilled out left and right, and the blue lines delineate distinct channels that we can recognize, fossil beds, if you like. We look at these channels and we see that they cut across the fan system, and to us they suggest that this fan did not form in a single instant, but this records some duration of a process.